So in our Introduction to Object-Oriented Programming video, we made this Husky class for potentially storing information about students at UConn, maybe in the UConn database, for instance. Now today we're going to be learning about subclasses, and subclasses are child versions of classes that inherit all of the properties of their parent class and grow upon them, and perhaps have some more attributes and some more methods, but otherwise keep everything from their original class. Now I said the word inherit there. Subclasses are an example of class inheritance. And so we can say that this subclass we're going to make inherits all the properties of Husky. And so that subclass we're going to be making is for engineering students. And so to make that subclass, I will say class engineering student. And then in parentheses, I will write Husky. And I'll write pass. And so now what we've done is told Python that Husky is the parent class of our subclass engineering student. And so if I change these two to say engineering student, and if we run our code, you will see that now, despite that there's nothing really being defined in lines 11 and 12, and we're creating instances of engineering student, it has all of the properties that Husky has. So see, we've just pulled the name attribute and we just pulled the get description method from Husky, because Python sees that we want to make a subclass and takes all the properties of Husky and applies them to the engineering student. And so if we go into the Python shell as well and write student_1, you'll see that we did make an engineering student object as opposed to a Husky object. And so, but instead of writing pass here, we can build and add more methods and more attributes to engineering student. So one example of something specifically engineering students do a lot is complain. And so if I write def complain and self, and then we can print the engineering student complaining. There we go. And this is not an attack on any specific engineering student, but this is generally something that engineering students will do a few times within their career. So it's important they have a method to do so. And so now if we come down here and write complain and run this, you will see that this indeed does print. And actually, so the reason we got none here is because we printed what the complain method returned, which in our case, it didn't return anything. It just ran this print statement. So we would actually go ahead and not print that. And as you can see now, we don't get that none there. And so now if we want to add more attributes to the engineering student, we will again change our dunder init method. And so currently we're inheriting the Husky's dunder init method, but if we want to add more attributes, we need to make a new one. And so if we write init and then grab all of these same properties that we had before, but maybe we add a new one, major, because there's a good couple of majors in the engineering school. And so now here, at the very least, I'll write self.major equals major, but we could, in theory, copy everything from the Husky class init into the engineering student init method. But that's not what we want to do, because we're good computer scientists and we should not have to write code or copy and paste code a bunch of places. And we should be able to refer to this somehow. And that way of referring to that is using something in Python called super. And what super is going to do is it's going to let us access everything that was inside of our original Husky parent class, or superclass, if you will. Superclass and subclass are two other terms that are used in these situations. And so if we run this super, what super does is it will return Husky and allow us to use all of the methods defined specifically in Husky in our engineering student class, if we were to overwrite them. And so since we're overwriting the dunder init method, we can go here and refer to Husky's dunder init method as so, and we can pass through the name, the email, and the year. And so and actually, let me comment this out for you first to show you what this will do if we don't have this method. It'll say that init is missing a positional argument because I forgot to include the positional argument. But if we include that Mike and I are both CS majors, then our new error is that CS student doesn't have a name, and that's because we never defined self.name. But if I add this line of code referring to the Husky classes init method, you'll see that it's able to define all of our previous attributes and then tack on our extra attribute along with that. And so the last thing we can do with subclasses, besides build off of them, keeping our old methods, and add new attributes inside of dunder init, is actually overwrite these old methods. And so one example of something we could overwrite is getDescription. So if I write def getDescription, now what I can do here is return an engineering or how about this? I'll go, they are an engineering student. And so if I return that, now getDescription, wow, I can't spell, will print that they are an engineering student, or not, because I spelled description wrong somewhere. Get description, get T-I-O-N, there we go. Thin, and then they are an engineering student, pulled from this method as opposed to our old method. But again, if we want to refer to the old Husky getDescription, we have a way of doing that as well, which is with this super method, or super function. And so we write super, and then getDescription, then this is actually going to run our old getDescription method with all of the engineering students' attributes. And so what this line of code will do is it will run the previous getDescription method with all of our attributes, and then with all of the engineering students' attributes, and then tack on this extra line of code. And so the importance of this is that it just lets us refer to our previous methods that we've created after we redefine them. And that would be helpful if we're building upon a method but still want to call the previous method inside of it, for instance. And so as you can see, if we run this, now it will say that Mike graduates and that they are an engineering student. And so this is just one example of creating subclasses inside of Python, but there's countless others you can think of. One example that I've done on my own is I made like a game class, and then I made subclasses of that game for different specific games, maybe tic-tac-toe, checkers. They're all games, so they all have some specific things that they refer to, but otherwise they have their own specific attributes and methods as well. And so this is a good way of modularizing your code and building upon what you've already created. And so thank you so much for watching, and I hope this helped you. Best of luck.